I'm here to talk to you about limiting reactants today. So you, by this point, know how to do regular stoichiometry problems. And now I'd like to teach you how to do limiting reactant stoichiometry problems. Okay, so before you were given one piece of information about one of your substances, and now you're going to be given information about two different substances and be asked how much can you make. Okay, so here's the first problem we're going to face. The first problem says, how many grams of water can I make from 14 grams of hydrogen and 100 grams of oxygen? Okay, so we don't know how to solve that yet, but let's keep reading. It says the idea here is simple. Do two stoichiometry calculations. One will convert 14 grams of hydrogen to grams of water, and the other will convert 100 grams of oxygen to water. The answer, which gives you the smallest amount of product, will be the correct answer, and the reactant, which gives you this answer, is called the limiting reactant because it runs out before the other one did. Okay, so we can see how this works with sandwiches. If I make a very boring sandwich from 2 slices of bread and 1 slice of cheese, I can ask myself a limiting reactant problem like this. How many cheese sandwiches can I make using 500 slices of cheese? 500 slices of bread and 2 slices of cheese. Okay, well, it's pretty simple and you can probably figure it out in your head. That's a lot of bread and we're feeding a lot of ducks to the park afterwards, okay? So based off the 500 slices of bread only, you can make 250 sandwiches, okay? But based on the 2 slices of cheese, you can only make 2 cheese sandwiches. So you're going to be able to make 2 sandwiches total and then just have a lot of leftover bread, okay? So cheese was our limiting reactant. Now, just because something was a limiting reactant in one problem doesn't mean it's always going to be a limiting reactant, okay? So let's do an example using the one from above, the hydrogen and oxygen one. Okay, so remember, the way we're going to solve these, and no, there isn't an easier way to do this. You can't just look at it and say, oh, well, there's more hydrogen. So actually, there's not. There's less hydrogen, so it's going to be hydrogen that's the limiting reactant. No, because hydrogen is, if you're thinking about it in terms, remember, stoichiometry is in terms of mole ratios. That's 14 moles, basically, of hydrogen. And if this is oxygen gas and it's 31.998 grams per mole, that's only about 3 moles of oxygen gas. Okay, so I'm going to rewrite my equation here. You guys are probably used to seeing it now. We've got 2 H2Os giving us 2 H2s plus an O2. Okay, and I'm going to start with the first thing I'm given. I have 14.00 grams of H2, and I have to go to grams of water. Okay, so first I'm going to get rid of grams of H2. So grams of H2 has to go down here. There are 2.016 grams of H2 and 1 mole of H2. Okay, and then for every 2 moles of H2, we get 2 moles of H2O. Okay, so now we're at moles of H2O. So now we can say, all right, for every 1 mole of H2O, we get 18.015 grams of H2O. Okay, and let's solve it out. We'll put it in our calculators. Okay, my answer is going to be limited to 4 sig figs. So I've got 14.00 divided by 2.016 times 18.015. that gets me 125.1 grams of H2O. Now that's how much I can make based on hydrogen gas. So now let's see how much we can make based on oxygen gas. Okay, so we were given 100.0 grams of O2. Well, for every 1 mole of O2, we get 31.998 grams of O2. Okay. And for every 1 mole of O2, you know what I just realized? That I wrote this equation backwards, but it doesn't really matter. It should be written as, the mole ratios are the same. Gives me 2 H2Os. There we go. That's better. For 1 mole of oxygen, we get 2 moles of water. And then again, our last step is going to be 18.015 grams of water are in 1 mole of water. So I'm going to do 100 divided by 31.998 times 2 times 18.015. And I get to have 4 sig figs again. So my answer is 112.6 grams of H2O. Okay, so the one that is the lowest is the amount that we can actually make, because based on hydrogen, we can make 125.1 grams. But based on oxygen, we can only make 112.6. So we can only make 112.6 grams of H2O with the materials that we were starting with. Okay, so that is our first example. Let's do another one. You combine 10 grams of hydrogen gas and 15 grams of oxygen gas. Okay, how many grams of water vapor are made, and what is the limiting reactant? Okay, so 10 grams of hydrogen gas. We're going to do the same thing, guys. 10.0 grams of H2. For every 1 mole of H2, we're going to get 2.016 grams of H2. And then for every 2 moles of H2, we get 2 moles of H2O. And for every 1 mole of H2O, we get 18.015 grams of H2O. All right, so we have 10 grams divided by 2.016 times 18.015. That gets me, I get 3 sig figs, so I get 89.4 grams of water. That's a lot of water coming from 10 grams of hydrogen. So let's check out oxygen gas. So we have 15.0 grams of O2. Okay. For every 1 mole of O2, I get 31.998 grams of O2. And every 1 mole of O2 gives us 2 moles of H2O. And for every 1 mole of H2O, we get 18.015 grams of H2O. So 15 divided by 31.998 times 2 times 18.015. We get 16.9 grams. So again, the amount of water made, so the amount of water is going to be the lowest amount. So it'll be 16.9 grams. And my limiting reactant, my LR, is O2. Now, again, it's not always going to be O2. It's going to be based on what you're given in your problem. So let's say you have 1 gram of hydrogen gas and 65 grams of oxygen gas. Okay. In that case, hydrogen would be your limiting reactant. Okay. So let's do a few more examples. If 5 grams of copper metal react with a solution containing 20 grams of silver nitrate, which reactant is limiting and what mass of silver is produced? Sometimes you have more than one product, so it's important to know what you want to actually achieve. Do you want silver or did you want copper nitrate? In this case, we wanted silver. Okay, so I know I'm going to need a couple of molar masses, and I wrote them down. So I know that copper, this is right off the periodic table, BT dubs. Copper is 63.546 grams. Ag, silver, is 107.868 grams. And silver nitrate, silver nitrate we need, is 169.872 grams. Those are the molar masses. So I'm just providing them for you because calculating molar mass is annoying, but it needs to get done. Okay, and we already have a balanced chemical equation. That's good. Okay, so we're trying to go from grams of copper to grams of silver. So first we're going to do number 1, grams of copper to grams of silver, and then we're also going to do grams of silver nitrate to grams of silver as well. So we have 5.00 grams of copper in 1 mole of copper. We've got 63.546 grams of copper. Okay, and our mole ratio for every 1 copper, for every 1 mole of copper, we get 2 moles of silver. And for every 1 mole of silver, we get 107.868 grams of silver. Now, it's important to note, guys, that you can determine what your limiting reactant is based on the number of moles. So we could if you're just asked for who your limiting reactant is, but most times you're going to be asked what your limiting reactant is and how much of the product is made. Okay. So let's solve this one. We've got 5 divided by 63.546 times 2 times 107.868. I get 3 sig figs. So my answer comes out to be 16.974. So then my answer will be 17.0 grams of Ag. Okay. So now let's figure out what our other substance can give us in terms of Ag. Okay. So if we have, so number 2, we're going to go from grams of AgNO3 to grams of Ag. So we're starting with 20.0 grams of AgNO3. We're going to get rid of grams of AgNO3 and get moles. So in 1 mole of AgNO3, we get, it says 169.872 grams of AgNO3. Okay, well, my mole ratio for every 2 moles of AgNO3, we get 2 moles of Ag. And then for every 1 mole of Ag, you get 107.868 grams of Ag. So 20 divided by 169.872 times 107.868. And I get 3 sig figs. This gets me 12.7 grams of Ag. Okay, so my limiting reactant then, is going to be AgNO3, and my amount made is going to be 12.7 grams of Ag, because it's the smaller amount. Okay, let's do another example, and I'm going to teach you something different. It's like an offshoot of this. Oh, look at this. There's no equation. I'm going to have to use your knowledge from previous sections to figure it out. Okay. We've got potassium hydroxide. So I'm going to write my equation, potassium hydroxide and ammonium sulfate. So ammonium is a +1, sulfate's a -2, so it's going to be NH4,2SO4. They're going to switch partners. So we're going to get K2SO4 plus NH4OH. And of course, now we have to balance it. Okay, so I'm going to put a 2 here and a 2 here. Okay. And I know, so it says 20 grams of potassium hydroxide, so 20 grams of this first thing, react with 15 grams of ammonium sulfate, right there, ammonium sulfate, okay? So what am I even looking for? So determine limiting reactant, yeah, but I don't know what I'm looking for yet. Calculate the grams of potassium sulfate produced. Cool, I have that now, okay? All right, so let's get started. All right, so I know that I'm going to need some molar masses, so let me write them down. Where do I want to write it? Molar, I'm going to write it up here. KOH's molar mass is 56.105. Ammonium sulfate is 35.406. Oh, wait, no, it's not. Sorry, ammonium sulfate is, that's ammonium hydroxide. Ammonium sulfate is 132.13. And potassium sulfate is 174.25. Okay, so that way we have our molar masses, we're ready to go. And this little mark here is bothering me, so I'm going to erase you. There you go. Oh, now I shut the whole thing down. Not good. Let me get back into sharing. Okay, so let's start with potassium hydroxide. We got 20. Come on, lady. Get it together. Where's my pen? Okay, come on. I'm going to have to go back. Here we go. Got it back. Okay, so we're starting with 20.0 grams of KOH and we want to go to grams of K2SO4. Cool. Let's do it. 20.0 grams of KOH for every 1 mole of KOH. We get 56.105 grams of KOH. Okay. And then our balanced chemical equation for every 2 moles of KOH, I get 1 mole of K2SO4. And for every 1 mole of K2SO4, I get 174.25 grams of K2SO4. So let's solve that out. We'll have 3 sig figs. 20.0 divided by 56.105 divided by 2 times 174.25. That gets me 31.1 grams of K2SO4. Okay, so now we've got 15.0 grams of NH4 2SO4. We'll get rid of grams of that. So in 1 mole of, let me turn that into an N, NH4 2SO4, there are 132.13 grams of NH4 2SO4. Okay, and so now we have to get rid of moles of NH4 2SO4. Well, for every 1 mole of NH4 2SO4, we get 1 mole K2SO4. And then that last step is always the same, 174.25 grams of K2SO4 gets me 1 mole of K2SO4. So 15 divided by 132.13 times 174.25. That gets me 19.8 grams. So my limiting reactant, is NH4 2SO4, and the amount made is 19.8 grams. Hey, but don't you ever wonder, like, I wonder how much of the other thing is left over when this reaction is completed? Because I wondered, okay? In our sandwich example, we ran out of cheese first. We had leftover bread, and the reactant that isn't completely used up is called the excess reactant, which means we have an extra of it, okay? So we can calculate the amount of excess reactant, okay? We start with a limiting reactant and solve for the excess reactant. And this will tell you how much of your excess reactant is actually used, okay? So let's look at our example. Okay, so we have 500 slices of bread. So let's say we know that we have 2 slices of cheese, and that's our limiting reactant. Well, I know for my sandwiches, it takes 2 slices of cheese. No, it doesn't. It takes 1 slice of cheese, Mrs. Berger. Get it together. It takes 1 slice of cheese for a sandwich. And 2 slices of bread. So what am I going to use up? I'm going to use 4 slices of bread. Okay, so then how much left over do I have? Well, I started with 500 slices of bread. I just subtract 4, so that's going to get me 496 left over. Okay, so now let's calculate the excess for all of our other problems. Okay, I'm not sure if I left myself enough room, but we'll try. Okay, so our limiting reactant for this first problem was oxygen. So I'm going to start with oxygen. So to get excess, I'm going to start with limiting reactant and go to the excess reactant to find out how much used. Okay, so oxygen was our limiting reactant. We had 15.0 grams of O2. And we want to go to grams of H2. Okay, so for every 1 mole of O2, there are 31.998 grams of O2. I'll zoom in here. Okay, and for every 1 mole of O2, we use up 2 moles of H2 in this equation. And for every 1 mole of H2, it's 2.016 grams of H2. So we're going to do 15 divided by 31.998 times 2 times 2.016. So that gets us, for 3 sig figs, 1.89 grams of H2. So that's all we used. That's all we used in this reaction. Well, let's look back to what we started with. We had 10.9 grams. We started with 10.9, so subtract answer from original amount. Okay, so we started with 10.0. We're going to subtract 1.89. And remember, sig fig wise, we have to round to the 10th place because that's as far out as the 10.0 goes. So we're going to do 10 minus 1.89. It's going to get us 8.11, which we're going to round to 8.1. Okay, so we have 8.1 grams of excess H2. Okay, so we're going to sound really smart right now. You ready to sound smart? All right, so when you react 10 grams of hydrogen and 15 grams of oxygen, you produce 16.9 grams of of water, and you are left with 8.1 grams of excess hydrogen gas. Very fancy. Okay, now let's try this next problem. Okay, our limiting reactant here was silver nitrate. So let's start with the amount of silver nitrate. So let's get our excess reactant down here. So we're going to start with 20.0 grams of AgNO3. And our goal is to figure out how many grams of copper it takes to react with that many grams of silver nitrate. So we're going to go silver nitrate to copper. Well, in 1 mole of silver nitrate, we get 169.872 grams of silver nitrate. Okay, and then our mole ratio, it was 2 to 1. For every 2 moles of silver nitrate, we get 1 mole of copper. And for every 1 mole of copper, it was 63.546 grams of copper. 20 divided by 169.872 divided by 2 times 63.546. I get 3 sig figs here. I get 3.74 moles. I'm sorry, not moles, grams of copper used. Okay, so how much of my copper is left over? Well, we started with, so excess is going to be start minus used. We start with 5.00. We're using 3.74. We get 1.26 grams. So we have 1.26 grams of excess copper. Okay, so again, let's try and sound smart, and hopefully Mrs. Berry can say it correctly. When 5 grams of copper and 20 grams of silver nitrate are reacted, 12.7 grams of silver are produced, and we have 1.26 grams of excess copper. There we go. Okay, with this one, I didn't leave myself a lot of room. So I think I'm going to open up another document to try and solve this one. Or I can try to do it. Try to write this right here. Limiting reactant, NH4 to SO4. Amount made is 19.8 grams. I underestimated how much room I would need for this. I'll erase this. Don't worry, I'll zoom way in so that it doesn't look too small. So now our limiting reactant was ammonium sulfate because we can only make 19.8 grams from it. So we're going to start with that 15.0 grams of ammonium sulfate. And we're going to solve for potassium hydroxide. Okay, so we're going to get rid of ammonium sulfate, 132.13 grams of NH4 to SO4 gives us 1 mole of it. Okay, now we're going to go for our mole ratio. Okay, so for every 1 mole of NH4 to SO4, we used 2 moles of KOH. And for every 1 mole KOH, it's 56.105 grams KOH. Okay, so let's do it. 15 divided by 132.13 times 2 times 56.105. Okay, that gets me 12.7. So 12.7 grams were used. Well, we started with 20 grams. So let's figure out our amount of excess. We started with 20.0. We're going to subtract 12.7. And I'm going to use a calculator so I don't make a fool of myself. That gets me 7.3 grams of excess KOH. Okay, so if we want to talk this whole problem through, we can say that when 20 grams of potassium hydroxide and 15 grams of ammonium sulfate are reacted, we produce 19.8 grams of potassium sulfate, and we have an excess of 7.3 grams of potassium hydroxide. So today we learned how to do limiting reactant, and we also learned how to do excess reactant, okay? And I hope you have a great afternoon. I'll have to stop recording.